Today's date is August 3rd, 2016. Sunrise over the skyline at Dubai this morning will be at 5:47 local. Under clear skies, the forecast for the day ahead is pretty typical for this time of the year, with surface temperatures expected to peak at almost 50 degrees centigrade by noon. Home to one of the largest Gulf carriers, Emirates, Dubai International Airport is a perpetual hub of activity, 24 hours a day, 7 days a week, 52 weeks a year. This year alone, the airport will handle just over 83.5 million passengers, making it the third busiest in the world, while also facilitating the movement of some 2.5 million plus tons of freight. These numbers being achieved through nearly 420,000 individual aircraft movements. Unknown to anyone, however, is the fact that of the numerous expected arrivals this morning, one in particular will stand out from all the others. With its arrival, Dubai International will be plunged into a chaotic state of near paralysis, while at the same time those in the skies immediately above will be forced to reassess, adapt, and implement contingency procedures in order to get their aircraft safely back on the ground. The arrival in question will be Emirates Flight 521. Operated by a Boeing 777-300 series aircraft, registration Alpha 6 Echo Mike Whiskey. On board will be a crew complement of 18, comprising of 2 pilots and 16 cabin crew, along with a booked load of 282 passengers. As we speak, the aircraft itself will still be some 3,000 kilometres or so to the southeast, preparing for its departure from the Indian city of Thiruvananthapuram, also known as Trivandrum. The sector, by Emirates standards at least, is planned at a fairly modest 4 hours 15 minutes, which, all going according to plan, should have the aircraft touching down in Dubai just before 12:30 in the afternoon local time. Once airborne and finally en route, 521's progress towards Dubai will be largely unremarkable. In general, the forecast weather for its arrival will be good, although during descent an updated weather report for Dubai International will suggest that arriving crews may well experience low-level wind shear during their approach to the airport, which, given the extremely high surface temperatures, won't come as any great surprise to the crew. Wind shear is the term used to describe observed variations in wind velocity and/or direction over a relatively short distance. These rapid changes can be either horizontal or vertical in nature. Horizontal shears usually occur where the flight path of an aircraft passes through a windshift plane, for example with the crossing of a cold front, where the respective wind directions on either side of the front differ greatly. Vertical shears, on the other hand, are most often associated with the approach phase of flight, while the aircraft is in close proximity to the ground, and as such are thus potentially more problematic for pilots to deal with. These rapid wind velocity or directional changes can drastically alter lift, indicated airspeed, and thrust requirements to the extent that in extreme cases the pilot's capability to recover may well be compromised. What causes such phenomena is perhaps a discussion for another day. However, in the context of what's about to happen to Emirates 521, it's probably sufficient to say that such effects can be readily caused by both environmental factors, which inject a level of instability into the environment, as well as mechanical factors, such as environmental disturbances caused by the presence of obstacles, be they natural or man-made in nature. The crew of 521, in having received the report, will brief accordingly and formulate a contingency plan should such conditions eventually be encountered. Subsequently, the aircraft will be vectored for the ORNAV approach onto runway 12 left. This type of approach, unlike any other, doesn't rely on any external or ground-based navigation aids. Rather, satellite GPS positioning facilitates the aircraft with lateral and vertical guidance to a target point 50 feet above the landing runway threshold. For the majority of the approach, the flight path will remain stable. However, as the captain, who will be the handling pilot at the time, attempts to reduce the rate of descent and flare the aircraft for landing, a combination of wind effect, high ambient temperatures and tailwind conditions will cause the aircraft to significantly float just above the runway surface. Stubbornly refusing to settle onto the concrete below, the captain will eventually decide to abort the landing and perform a go-around. As the aircraft subsequently climbs away with the gear in transit to the retracted position, inexplicably, the aircraft will begin to lose height and a mere 18 seconds later would settle back onto the runway, just over 2,500 metres from where it crossed the landing threshold. As all 230 tons of Emirates 521 finally comes to a stop, a post-accident fire will completely engulf and destroy the aircraft. Miraculously though, all 300 persons on board, passengers and crew, will safely evacuate during the 6 minutes and 40 seconds which immediately follow. But what exactly will happen to 521 as it attempts to touch down on runway 12 left? What will cause the commander to initiate the go-around? Why will the go-around attempt be unsuccessful? And what role will the environmental conditions play? How did such a technologically advanced aircraft succumb so easily? How well had the crew been trained to deal with this type of situation? And why, at over 6.5 minutes, will it take so long to complete the evacuation? With the broad overview now of what will transpire at Dubai over the coming hours, come with me as I answer all of these questions and more, and explain in detail what really happened to Emirates Flight 521.
Calling out Mayday.
As 521 crossed the coast of Oman, attention on the flight deck turned to preparing for the approach into Dubai. The captain occupying the left-hand seat would, in the subsequent report, only be identified as a UAE national aged 34, with just under 7,500 hours of total flight time, the vast majority of which had been obtained on the Boeing 777. Relatively inexperienced in the command role, his total command time had extended to just over 1,100 hours, all of which had been gained on this particular aircraft type. Within the previous 12 months, he had operated a total of 135 flight duties, which had seen him complete 66 landings as the designated flying pilot, a relatively small 14% of which had been executed at his home base of Dubai itself. His colleague, occupying the right-hand seat, again would only be subsequently identified as a 37-year-old Australian citizen. His total time was slightly greater than that of his captain, extending to just under 8,000 hours, almost 1,300 of which had been obtained on the 777. The breakdown of his previous 12 months of flying wasn't all that dissimilar to that of his captain. His flight records showed that during the same period he had completed 130 flight duties, resulting in the completion of 58 landings as handling pilot, 29, or exactly 50% of which, had been carried out at Dubai. A weather forecast, known in the business as a TAF, or a terminal area forecast, issued for the Dubai area and covering a 6-hour window which was to commence 2 hours prior to the jet's arrival, indicated that winds were largely expected to be out of the east, with visibility remaining reasonably good at a constant 7,000 metres in clear skies. As 521's arrival time approached, it was anticipated that the surface wind would slowly back to a northerly direction and strengthen ever so slightly. As early afternoon approached, the wind's direction was again expected to veer to the east, with a 30% chance that during this time frame it would strengthen still further from 8 to 16 knots, with the potential for occasional gusts up to a maximum of 26. This anticipated increase in wind strength would most likely lift dust and sand into the atmosphere, consequently reducing the visibility overall to values as low as 3,000 metres at times. Being a forecast and thus by definition covering a rather large time window, these TAFs are rather general in nature. Thus each airport in addition will issue its own hourly METAR, a specific observation of what the weather is actually doing in more or less real time, with this observation further refining the general forecast for the 60 minutes or so following its publication. The METAR issued for Dubai International at 8:30 Zulu or 12:30 local that afternoon, only minutes before 521's arrival, indicated that the actual conditions at the airfield were showing a generally easterly wind of about 15 knots, which was varying slightly by about plus or minus 30 degrees or so. With that, the overall visibility was remaining pretty good at 6,000 metres, with the noonday temperature already a punishing 48 degrees centigrade. All in all, a report which was pretty much in line with the forecast issued some hours previous. That said, however, what this observation did include was a further caution in relation to possible wind shear encounters on approach. Such a caution had also been incorporated into the ATIS broadcast of 800 Zulu or 11 o'clock local time, this being the report that the crew would have obtained while approaching the Oman coastline. Whereas METARs are issued on an hourly basis, an ATIS, or an Airport Terminal Information Service, is a broadcast pertaining to a specific airport every 30 minutes or so. Such reports not only refine the actual current weather conditions, but typically also include operational information which will be of relevance to the pilots, for example the runway and type of approach in use. This report, identified as ATIS Information Zulu, stated that moderate wind shear was to be expected on approaches to all runways at Dubai International for at least the next hour, with updates to follow if necessary. In due course, 521 was sequentially handed over to the area controller in Dubai, as the 777 descended through flight level 160. On initial radio contact, the crew confirmed that they had indeed received the latest ATIS for the airport, that being Information Zulu, and were told to expect the RNAV approach to runway 12 left. The time was now 8:17 Zulu, or 17 minutes past 12 in the afternoon local time, a mere 20 minutes before disaster. I alluded earlier to the fact that these wind shear events could be caused by environmental or mechanical influences, specifically in relation to Dubai International Airport in the early afternoon hours of August 3rd. Meteorologists confirmed that the conditions being experienced were being caused by the combined influencing effects of two local low-pressure areas. The first was centred approximately 300 kilometres south of the airport, having a central pressure of 998 hectopascals. The second, being a manifestation of the extremely high ambient temperatures, had developed along the coast about 55 kilometres southwest of the airport, with a central pressure of 992 hectopascals. The combined effect of these two low-pressure areas were to act in such a way as to delay the onset of the regular afternoon sea breeze at the airport. Furthermore, once the sea breeze had started to manifest itself, the effect of these two pressure areas would have been to considerably slow its development from north to south across the airdrome, and in so doing, would ultimately give rise to an extended period of anticipated shear. Indeed, unknown at the time, but subsequently as part of the accident investigation, the Meteorological Office were to publish data of the 2-minute average wind for the runway 12 left threshold. This data revealed a noticeable trend whereby the wind direction at 12:25 local, just 12 minutes before the accident, had indicated as coming from a direction of 120 degrees magnetic, this resulting in a headwind component for all arriving traffic onto the runway. However, by 12:30 local, a mere 5 minutes later, the same data stream showed that the wind had subsequently veered to a direction of 280 degrees magnetic, implying that whatever headwind component had existed had within that very short time frame been replaced by a tailwind component, and the magnitude of this tailwind was at times not insignificant. In the 7 minutes immediately leading up to the accident, the threshold surface wind speed varied between 4 and 14 knots, with a wind gust of 25 knots being recorded at 12:37 local, the exact time of the accident, and one again of 29 knots 1 minute later. Albeit a fairly simplified explanation, as airflow passes over the upper cambered surface of the wing, it produces lift. As 521 descended towards the tarmac surface of runway 12 left, passing through 20 feet, the 777, in light of what's just been uncovered, was experiencing a tailwind component of 11 knots. Had these conditions been consistent and maintained throughout the flare and touchdown, then in all likelihood the landing would have passed off without incident. However, history would recall that this wasn't to be the case. Unlike the case of a performance decreasing or negative shear, where headwind gives way to tailwind, 521, in light of the wind conditions just mentioned, in fact experienced the complete opposite. As the aircraft attempted to flare and touch down on the runway, within the last few feet of its descent, the tailwind, which had been experienced on short finals, rapidly gave way to a steady and ever-increasing headwind the further the aircraft travelled down the length of the runway. This was not a performance-decreasing shear in the traditional stereotypical sense, but rather quite the opposite, a performance-increasing shear. The reason it's called a performance increasing shear can be explained by reference to the general lift equation. Lift can be expressed mathematically as a half rho v squared SCL, where rho relates to the environment's density, v to the velocity of the relative airflow over the wing, s the wing's surface area, and Cl the lift coefficient of the aircraft's wing, specifically the unique lift characteristics of this particular airfoil and its angle of attack. In this performance increasing shear, as the aircraft flares and the tailwind component gives way to a headwind, the speed of the relative airflow over the wing will increase, while all other components of the equation will remain constant. Therefore, with the value of v increasing, the resultant lift being produced by the wing will likewise increase, and the aircraft will unintentionally continue to fly or float, despite the pilot's intentional effort to actually diminish lift and allow the aircraft safely settle onto the runway. Although the 777 is equipped with an advanced wind shear detection system, at no point during the approach did it provide an alert to the crew as to the presence of an environmental wind shear condition. The reason's twofold and sadly very uncomplicated. Firstly, the wind shear detection system has been designed to warn of transitions from headwind to tailwind, or in other words, a performance decreasing shear. However, the prevailing conditions as 521 crossed over the threshold of 12 left meant that the aircraft would experience the complete opposite, as tailwind gave way to headwind, resulting in a performance increasing shear. This increase in kinetic energy causing the aircraft to float. Alas, where detection of a performance decreasing shear is a standard fit for the 777 type, the system's capability to detect a performance increasing shear, such as the one experienced, is an optional extra, which simply hadn't been installed in the Emirates 777 fleet. The second reason for the absence of any warning highlights the system's Achilles heel. Air movement is invisible, although its effects are not. So in order to see the shear, the system relies on localized radar returns of even minute levels of moisture in the air to detect changes in wind speed and direction. And at 48 degrees centigrade, there wasn't too much of that at the time of the crash. So, given the conditions at the time, even this incredibly sophisticated piece of kit was rendered effectively useless. As the time approached 8:15 Zulu, 12:15 in the afternoon local time, 521 joined the left-hand downwind leg of the approach for runway 12 left. At this moment in time, the accident event was a mere 22 minutes away. Although the winds were now starting to veer towards a more westerly direction, during that period between 12 local and 12:23, the prevailing winds had generally resulted in the steady headwind component on runway 12 left, and within this time frame 12 aircraft had landed without incident. From a procedural perspective, all arriving aircraft into any large airport such as Dubai will do so under strict instrument flight rules. What this means is that the aircraft are obliged to follow specific published arrival routings akin to the flow of water through a pipe, whereby all traffic is managed both laterally and vertically to a point where they can commence the final approach to landing. The term instrument flight rules denotes the fact that such procedures are to be conducted with reference to the aircraft's onboard instrumentation, rather than by any reference to any external visual landmarks. The management of such procedures and the aircraft conducting them rests not surprisingly with the staff of the air traffic control system. In so doing, each specific section of the procedure is overseen by a dedicated controller. For example, from initial entry into Dubai's airspace, the crew of 521 would have maintained direct radio communication with one of the airport's area controllers. Typically, they will oversee the aircraft until its arrival into the immediate airport environment, at which time the flight is usually handed over to the next controller in the sequence, namely the approach controller. It is his or her responsibility to provide adequate separation between aircraft in close proximity to the airport, while sequencing them for their final approach to the landing runway. Once established on this final approach, and within about 4 to 5 miles from touchdown, the approach controller will again hand the aircraft off, this time to the tower controller, who ultimately clears the aircraft to land. The process continues still further even after landing, wherein the tower controller hands the aircraft off to the ground controller, who, as the name suggests, manages the aircraft movement between the runway and its final parking position at the terminal building. This being the case as Emirates 521 finally established itself on the left-hand downwind for the landing runway, The flow of traffic being worked by the approach controller had at number 8 in a long line of inbound aircraft, all heading for the same runway. At the head of this inbound sequence were two company 777s, these being Emirates 621 and Emirates 337, both of whom landed on runway 12 left without incident. In the context of Emirates 521, events started to take a turn with the arrival of the third aircraft in the sequence, that being a Boeing 737 designated Iraqi Airways Flight 123 inbound from Baghdad. Having landed on runway 12 left at 12:24 local, the Iraqi crew advised the tower controller that they had experienced light to moderate wind shear on the latter part of the approach. Their comments were acknowledged, and they were subsequently handed off to the ground controller, while the tower controller turned his attention to the next arrival. This next arrival would be Air India Flight 993, a short-haul Airbus inbound from Goa. As he cleared 993 to land, the tower controller indicated that the surface wind was now 170 degrees at 12 knots, coincidentally resulting in a 7-knot headwind component, and made reference to the fact that the preceding aircraft had reported wind shear at the approach. His comments were acknowledged by the Air India crew as they continued with their descent towards the landing runway ahead. Of note, however, was the fact that while this interaction between the tower controller and 993 was taking place, the crew of Emirates 521 were still working the approach control frequency, and as such were not in a position to hear the tower controller's cautionary comments with regard to the previous wind shear reports. As Air India 993 descended through the last few hundred feet of its approach, the controller, from his position in the tower, noticed it execute a go-around, with him subsequently instructing it to climb straight ahead and maintain 4,000 feet on reaching. Next in the sequence was another Emirates 777, that being Flight 706 inbound from the Seychelles. As with 993 previously, having been cleared to land, 706 had likewise executed a missed approach from just above the runway surface. In the short time between both aborted landings, the subsequent investigation had revealed that the surface wind had veered to 240 degrees at 9 knots. The previous headwind component, in apparently no time at all, had now been replaced by a tailwind component of about 5 knots, meaning a tangible 12-knot shift within the space of only a couple of minutes. Surprisingly, no reason for either go-around had been reported to the tower, nor had the tower controller requested this information. Emirates 521 at this stage still had not been handed over to the tower controller, and as such was completely unaware of developing events. In the aftermath of the two go-arounds, the tower and approach watch managers discussed the wind conditions and the wind chill warnings on the ATIS. Initially, the approach controller had offered the tower controller more time separation between aircraft and final approach. However, ultimately both agreed that this would afford no meaningful solution to their growing problems, and that the overall traffic flow rate into the Dubai control area would have to be curtailed. At 12:32 local, Emirates 409 was cleared to land, without the tower controller passing any additional information to the aircraft. The surface wind of 250 degrees at 8 knots, now representing a consistent tailwind component of about 5 knots, although well within defined limits, was indicative of the general change which was taking place. 409, inbound from Melbourne, Australia, subsequently landed without incident. Next in the inbound sequence, and the aircraft immediately ahead of 521, was Emirates 545, another 777 inbound from Chennai, India. When it was cleared to land, the reported surface wind was given as 190 degrees 11 knots, again with no additional information being passed to the crew. In what was to be the first clear manifestation of how the conditions were starting to affect the inbound arrivals, 545, due to the increasing tailwind, had floated and ended up landing towards the end of the touchdown zone. This caused it to miss its assigned taxiway turnoff at Mike 9, and instead was forced to vacate the runway 2 intersections further down the runway at Mike 12 Alpha. Despite this, neither the crew of Emirates 409 nor 545 were to make any adverse reports to the tower with regard to the surface wind conditions. At about this time, the tower and approach controllers again discussed the prevailing wind conditions, as the threshold surface wind being displayed for runway 12 left was now indicating an increased 12-knot tailwind component. Confusing matters still further, was the fact that at the reciprocal end of the same runway, that being 30 right, the surface wind was also registering a tailwind component of, in this case, 16 knots. After much debate, both were convinced that a landing runway change would be inappropriate at this time. At 12:35 local, Emirates 521 was finally passed to the tower controller's frequency, with Emirates 565 following closely behind. Less than 60 seconds later, 521 was finally cleared to land on runway 12 left, with the surface wind being reported as 340 degrees at 11 knots, that being a 7-knot tailwind. Again, no reference was made by the tower controller to the fact that 2 aircraft in succession had recently gone around due to the sheer conditions. What happened over the next 90 seconds will subsequently be identified as a rapid series of environmental, technical and human links in an error chain, which ultimately culminated in the loss of the aircraft.
Long landing. Long landing.
Red head 4000 Emirates 521.
Don't sink, don't sink, don't sink.
Airspeed full. Airspeed full.
50, 40, 30, 20, 10, 5.
Do you see that?
I think 5 go around, 6 go around, and 54,000.
Go around Emirates 565. Okay, you need to check that at the end of 12 left.
I got it. Emirates 521, and the still coming down at 1. Yes, stand by 857, what is it?
Okay, hold the 3 Bravo, otherwise you can find them.
Emirates 565, concentration, and 54,000.
Passing 12 on time, 4600 565.
565, I'm saying green up 126.2.
126 to Emirates 565.
Emirates 521, and do you require any further detail on the landing center? Emirates 521, 165, go down there.
All stations on delivery frequency, I just need radio silence for now. Radio silence for the next 10 minutes. I will call you back.
The airside 2, whenever the ticket the runway 12 left.
To the runway 12 left. To runway 12 left, proceed to the aircraft. Fire 1 to runway 12 left, proceed to the aircraft. Do not wait for the light, proceed to the aircraft.
Dubai Emirates will be maintaining runway heading after overhead, just for information.
All fire vehicles proceed to the aircraft. Proceed to the runway, proceed to the aircraft.
And Dubai Emirates, sorry for insisting, but if you tell us what you planned with us, we might decide to divert right away to Alpha 2.
And all fire vehicles proceed to the aircraft. I repeat, proceed across all runways, proceed to the aircraft.
Fire 5, fire kilo 6 at the runway 12 right, and proceed to the aircraft on 12 left.
For all vehicles remaining to runway 12 right, just required to proceed to the aircraft. Runway is closed, next to runway.
Dubai Emirates on runway heading, our holding capability now is reduced to 7 minutes, please.
CJ 47, there's no delays on the time, just listen out for you.
Dubai 848, if there's no plan for us, we'd like to divert to Al Maktoum as well due to fuel.
47. I won't recommend that. Your delay is not determined. If you're not saying anything, just listen out. I will call it down.
Dubai Channel 515, we can hold for 40 minutes, otherwise proceeding to Undermine.
2203, listen out. Delay is not determined. If incident on the airfield, I'll call you back.
Okay, we can land at Ras Al Khaimah, Channel 515.
060, roger. Hold your position. Undetermined delay due to an incident on the airfield. At this stage, I have no additional information, but the airfield is temporarily closed.
We can hold for 0 minutes, here near 515.
Cutaway 731. No, nobody's moving anywhere at this stage. Indeterminate delay. The airfield is under control of fire services.
Okay, and can we land at Sharjah Airport, please? Roger, Lieutenant 030, expect charge at Channel 515.
Jordanian 611.
Yes, sir. Any delay for pushback or startup?
Jordanian 611. Affirmative, there's an indeterminate delay at this point for the airfield. I have no further information due to an incident. We'll call you back when we find something out. It will be a significant amount of time.
Thank you very much, sir. And we are on Charlie 555. Anytime we are ready for the thank you.
Understood.
In order to provide a chronological overview of events, the following slides will depict the last few minutes of Emirates Flight 521. In the lower left-hand corner is displayed the aircraft's calculated approach reference speed for its current weight of 229,789 kilos, that being 147 knots. To this is added a small buffer of 5 knots, which results in the actual approach speed the crew will attempt to maintain through the latter part of the approach until touchdown, at 152 knots. Below this is a continuous indication of the current headwind or tailwind component, and finally a planned depiction of the aircraft's relative position and progress along the landing runway 12 left. It's important to note that the approach was stabilised before 1,000 feet radio altitude, and as the aircraft descended through 930 feet radio altitude at 12:36 and 10 seconds local, the commander disengaged the autopilot and continued the approach with the autothrottle engaged, in accordance with the operator's policy, which stated that use of the autothrottle is mandatory unless unserviceable. With autopilot disconnection, the autothrottle remained in speed mode, and the flight directors remained on. At 12:36 and 22 seconds as the aircraft passed 750 feet radio altitude, with an indicated airspeed of 153 knots, the flight data recorder showed that the wind direction changed from a headwind to a tailwind component. At 12:36 and 40 seconds as the aircraft descended through 450 feet radio altitude at a speed of 156 knots, an automated minimums call-out was generated by the ground proximity warning system, and the commander announced landing, with the co-pilot providing feedback indicating that he had heard and understood the commander's decision. The flight crew received and acknowledged the landing clearance for runway 12 left from the tower, which gave the wind at 340 degrees 11 knots, this resulting in a tailwind component of approximately 8 knots. At 12:36 and 56 seconds on passing 190 feet radio altitude and at a speed of 152 knots indicated, The co-pilot suddenly announced 16 knots tailwind, his alert being acknowledged by the commander. During this time, while handling the aircraft, the commander had maintained the 777 on the nominal glide path at an average pitch attitude of 0.7 degrees. At 115 radio altitude and 157 knots indicated airspeed, the co-pilot further announced, with reference to the tailwind, reducing to 13 knots, this again being acknowledged by the commander. With this reduction in tailwind, the aircraft's rate of descent began to ease off, decreasing from 800 to 700 feet per minute, with an average pitch angle now of about 0.5 degrees. This was followed by a further automated GPWS, or ground proximity warning system, call-out of 100. The wind was now 310 degrees at 14 knots. At 12:37 and 5 seconds, the aircraft passed over the threshold of runway 12 left, at about 54 feet radio altitude and 159 knots indicated. 1 second later, at 12:37 and 06 seconds, after the 777 had flown approximately 100 meters beyond the threshold, as recorded by the flight data recorder, the commander initiated the flare at approximately 40 feet radio altitude with pull on the control column. At the start of the flare, the pitch angle changed from 0 to 0.4 degrees, and over the next 5 seconds, whilst the aircraft continued to descend just 7 feet above the runway surface, there was a steady increase in its pitch attitude from 0.4 to 2.6 degrees, with a corresponding decrease in its sink rate from 692 feet per minute towards 350. A further 2 seconds later, as the aircraft passed through 25 feet radio altitude, approximately 300 meters beyond the threshold, the autothrottle mode changed on the flight mode annunciator from speed to idle, and per design, the autothrottle motors began to drive both thrust levers back towards the idle stop, with engine instrumentation registering a corresponding reduction in engine power output. 2 seconds further still, and the airspeed decreased to 153 knots as the aircraft descended below 13 feet radio altitude. From 12:37 and 12 seconds local, at a height of 5 feet radio altitude, several pulls and pushes on the control column along with control wheel roll and rudder inputs were recorded by the aircraft's flight data recorder. The commander made a left roll input to the control wheel, and at about this time the cockpit voice recorder recorded his startled exclamation of "Whoops!" The indicated airspeed had increased to 160 knots, with the aircraft's ground speed beginning to show a downward trend from 176. This indicative of the winds starting to shift from a tailwind to a headwind component. With the aircraft floating just 2 feet above the runway surface, the indicated airspeed had increased to 165 knots, with the ground speed further reducing to 172. The rate of descent had now shallowed to a mere 80 feet per minute. The commander further exclaimed thermals, which the co-pilot acknowledged. Neither pilot had been aware of the increase in airspeed, however, because throughout, their focus had been on the external scanning of the runway environment ahead. The commander later stated that in an attempt to have the aircraft touch down, he had momentarily pushed the control column 3 times in order to lower the nose, this action being confirmed by the data recorded on the FDR. At 12:37 and 16 seconds, the aircraft rolled 3 degrees to the left due to the wind effect, and the commander corrected with right control wheel input. In response to this input, the resulting right bank of 7.4 degrees caused the right main landing gear to contact the runway, approximately 1,090 meters beyond the threshold of 12 left. Typically, the 777 flight crew training manual states that the normal landing flare distance is between 300 and 600 meters beyond the threshold, the whole process lasting in total for about 4 to 8 seconds depending on the approach speed, before touchdown usually occurs. 521 had exceeded those values by at least 500 meters. The right main gear contact with the runway caused it to untilt or enter the ground mode as recorded by the flight data recorder. Runway contact was made at an airspeed of 161 knots indicated. this being a full 14 knots above the landing reference speed of 147. Each main landing gear consists of a 6-wheeled bogie with an actuator assembly that tilts the bogie upwards by 13 degrees in preparation for landing and down 5 degrees for gear retraction. When the main gear is extended for landing, this tilted position of the bogie allows the aft wheels to contact the runway first. The whole assembly will then untilt, allowing the centre and forward wheels to sequentially contact the runway surface thereafter. Importantly, the design is such that tilt sensors are installed to electronically sense in real time the actual orientation of the bogie. As the bogie makes contact with the runway surface, the aircraft's weight on the gear will cause this 13-degree incline to reduce, and in so doing, as the tilt value decreases below 10 degrees, these sensors signal a configuration change from the tilt or airborne condition to the untilt or ground condition. The identification of this fundamental transition from air to ground logic is of significance for a number of aircraft systems, such as auto throttle, auto brake, and auto speed brake activation. Over the 6-second period between 12:37.16 seconds to 12:37.22 seconds, as recorded by the aircraft's flight data recorder, both main landing gear experienced a series of tilt-untilt or air-ground cycles, where repeatedly the aircraft actually bounced from gear to gear, with one or other of the main gears in isolation indicating it was on the ground, while the other was showing in the air. Additionally, there was a brief period of 2 seconds where simultaneous grounding of both gear was also recorded. The implications of this tilt-untilt sequence is extremely significant, particularly in the context of its impact on the aircraft's autothrottle logic. Another function of the autothrottle is to automatically activate the go-round mode once each of the following conditions has been met. Firstly, the autothrottle switch must physically be in the arm position, with the air-ground sensors sensing that the aircraft is actually airborne. Secondly, the aircraft must have captured the ILS glide slope, or, alternatively, the flap lever has been positioned to any of the extended positions. In other words, any position other than up. Finally, at least one of the 2 toga switches just forward of the thrust levers must be momentarily depressed. With all 3 conditions being met, the autothrottle motors will drive the thrust levers to the toga position, ensuring enough power for a subsequent rate of climb equivalent to approximately 2,000 feet per minute, while managing the required go-around speed and triggering the flight directors to provide for go-around pitch and roll guidance. The 777's maintenance manual states that the autothrottle will move the thrust levers from idle to the toga position in approximately 5 seconds, the equivalent to about 10 degrees of thrust lever movement per second. Boeing did additionally comment, however, that this rate of thrust lever movement shouldn't be considered linear over the entire range, as the rate of lever movement will be refined as the applicable thrust target is approached. The aircraft will consider itself on the ground and thus no longer in the air mode when either of the following conditions are met. Firstly, where the radio altitude indicating the exact height above ground is less than 2 feet for a minimum of 3 consecutive seconds, or secondly, irrespective of time, the radio altitude is less than 2 feet and the weight on wheel sensors for either of the main landing gear register an increased load, indicative of the fact that touchdown has occurred. Under such circumstances, the autothrottle is actually inhibited. Boeing stated that the reason for inhibiting the toga switches was to prevent pilots from inadvertently activating toga mode at or after touchdown, introducing potential controllability issues and the possibility of the aircraft unintentionally departing the runway. If the toga switch is pushed during this inhibited period, the autothrottle will therefore not automatically advance the thrust levers to the go-around thrust setting, nor will the flight directors provide pitch or roll guidance to fly the go-around maneuver. This inhibition period will cease once the aircraft is no longer in the ground mode, that is, weight is no longer sensed on the wheels, and the radio altitude is showing a value of more than 2 feet. In the scenario where the toga switch is pressed prior to touchdown with the intention of initiating a go-around, and subsequently the aircraft does touchdown, transiting from air to ground mode, the go-around execution will not be interrupted, and auto-throttle application of power will continue as expected. The toga switches I'm referring to here are 2 independent logic switches strategically placed just forward of each thrust lever. Their placement and design is such that either or both can be depressed by the pilot without the need to remove the hand from the thrust levers. As a result of this contact sequence, during the 6-second period, there were 2 automatic partial movements of the speed brake lever recorded on the flight data recorder. On landing, the speed brake lever, having already been placed in the arm position, will automatically deploy where the landing gear is less than 5 feet above the runway, and both weight on wheel sensors have sensed on-ground logic, or alternatively, both main landing gear are in the untilt or ground condition, and both thrust levers have been retarded to the idle position. Provided these conditions are maintained, the speed brake lever will automatically extend the full 60 degrees of movement from the arm position to the up position within about 1.5 seconds of touchdown. Of note, however, the speed brake lever will instead retract automatically if any of the above conditions are no longer valid. In retrospect, forward and backward movement of the speed brake lever would have been an indication to the crew of this cyclical main landing gear movement. However, with the flare being a visual maneuver, the attention of both pilots was forward, concentrating on the runway environment ahead. As such, being out of their line of sight, this speed brake lever movement went unnoticed, and apart from this lever movement, there was no other system indication that the aircraft had touched down and that transition from air to ground mode had actually occurred. The commander stated during his post-accident interview,
"Below 2,000 feet, we started picking up some tailwinds, and getting close to the runway, like 50 feet flare height, we had thermals. Updraft coming from the ground because of the heat, so it was pushing the aircraft up, causing a long flare. The aircraft was going towards the end of the touchdown zone, so I decided to go around."
with the co-pilot stating during his interview,
"The flare felt like it just wouldn't land. It was bumpy. I'd say we were definitely less than 50 feet at the initiation of the go-around."
The commander further stated that he had pushed the left toga switch and then called go-around, in an attempt to verify the commander's statement. And because the operation of the toga switch is not one of the parameters recorded by the flight data recorder, the investigation team performed a detailed analysis of the cockpit voice recording and confirmed that a click sound was indeed heard just before the commander made his call. A comparison was made between this audible click and the sound of a toga switch being depressed in the cockpit of a sister aircraft, using sound analysis and visual inspection of the respective waveforms. Even though the methods used were not sufficiently reliable to definitively identify the sound signature, there was, however, good similarity between the click sound on the CVR and the recording from the cockpit of the second aircraft, to ultimately allow the investigation team arrive at a conclusion that what they had heard was indeed most likely the sound of the toga switch being pushed, just as the commander had testified. However, by design, as I've already highlighted, with the aircraft having already entered the ground mode, this depressing of the toga switch had had no resultant effect on autothrottle operation, with the thrust levers thus remaining at idle. After crossing the runway threshold, the commander stated that his attention had been outside of the cockpit, focusing on the far end of the runway. He stated that his practice, in accordance with his training, was not to look at the cockpit instrumentation after the flare had been commenced. In addition, he stated that during the attempted go-around, he'd been focused on the aircraft's attitude, describing his state of mind as being tunnel-visioned. Thus, he said, he could not recall if there had been movement of the thrust levers from their idle position following his depressing of the left toga switch. His declaration to go around was immediately followed by a long landing automated cockpit enunciation from the Runway Awareness Advisory System, or RAS. He then pulled the control column rearward, and the 777's pitch attitude started to increase. 1 second after his go-around declaration, His co-pilot responded by saying OK, followed immediately by another, second long landing cockpit enunciation. These oral long landing alerts are generated where the aircraft fails to touch down within a predefined distance, equating roughly to the first third of the overall landing distance being available. In the context of Dubai's runway 12 left, being some 3,600 metres in length, the alert should have been triggered as the aircraft, still airborne, passed approximately 1,188 metres beyond the threshold. During his interview, the commander stated that he had had his right hand on the thrust levers when he pushed the toga switch, stating emphatically that his decision to go around had been made before the aircraft had touched down. He could not remember any changes in the flight director or flight mode enunciator having depressed the toga switch, but did remember pitching the nose of the aircraft up to approximately 7.5 degrees and observing a positive rate of climb. Separately, the flight data recorder confirmed that the aircraft had touched down for a duration of 6 seconds in total, and had travelled some 500 metres along the runway, with both main landing gears simultaneously in the ground mode for only 2 of these 6 seconds. Throughout, the 777's nose landing gear had remained in the air. At 12:37 and 22 seconds, in accordance with the normal go-around sequence, the commander called for the flaps to be retracted to the 20 position. Just 1 second later, both main landing gear transitioned back to the air mode, as the aircraft became airborne once again at a speed of 153 knots indicated, 6 knots above the approach reference speed, with the flaps not yet having started to transition. The recorded wind was now from a direction of 120 degrees, with a magnitude of 8 knots. With the co-pilot having moved the flap lever to the flap 20 position and verbally confirming his action, the aircraft continued to gain height, and as it reached approximately 47 feet radio altitude, he further announced positive climb. The commander in response called gear up, as the 777 climbed through 58 feet radio altitude at a rate of 608 feet per minute and an indicated airspeed of 145 knots. Thereafter, the rate of climb started to decrease. Shortly after the commander's gear-up call, the tower controller transmitted a modified missed approach instruction to Emirates 521, lasting approximately 3 seconds, to continue straight ahead and climb to maintain 4,000 feet. The co-pilot responded gear up as the selection was made, with the aircraft now climbing through 77 feet radio altitude at an indicated airspeed of 135 knots. He then read back the controller's instructions and changed the pre-selected missed approach altitude for acquisition from its previous setting of 3,000 feet. 2 seconds later, at 12:37 and 31 seconds, less than 12.5 seconds after pushing the toga switch, the aircraft attained its maximum height of 85 feet radio altitude at a speed of 131 knots, now 16 knots below the approach reference speed. With no power having been applied, and compounded by the drag associated with opening of the landing gear doors to accommodate retraction of the gear, the aircraft simply hadn't any energy reserves left to climb any further. 3 seconds after the aircraft had started to lose height, the commander called wind shear toga as the aircraft now sank below 67 feet radio altitude. Having already assumed the toga had been applied with his earlier depressing of the toga switch, the captain's call of wind shear toga was in response to his preconditioning that the anticipated wind shear environment could or was having a detrimental effect on his aircraft's performance. His intention with the call was to execute the wind shear escape manoeuvre, the first action of which was to apply full power on both engines. 1 second later, at 12:37 and 35 seconds, the commander, his right hand still on the thrust levers, advanced both manually in an attempt to deliver maximum thrust to the engines, as an automated don't sink cockpit oral alert was generated. This don't sink cockpit alert is generated by the enhanced ground proximity warning system, when there is an altitude loss after takeoff or during a go-around. It's a function of the height of the aircraft above the terrain and is enabled after takeoff or go-around when the landing gear or flaps are not in the landing configuration, staying enabled until the system detects that the aircraft has gained sufficient altitude. Shortly after, the co-pilot called out "check speed," followed by a cockpit automated airspeed low caution at 128 knots indicated, as the "don't sink" cockpit oral alert enunciated for the second time. Following these warnings, with the aircraft losing height at a rate of 800 feet per minute, the commander increased the aircraft's pitch still further to about 9 degrees in an unsuccessful attempt to regain the lost height. He again stated during his post-accident interview that "we noticed the aircraft speed dropping, so I applied maximum power because TOGA sometimes limits the thrust, and pushed the levers fully forward. The aircraft, though, continued to lose airspeed because of the shifting wind and wind shear. At that time I called wind shear TOGA." He stated that after gear up, the speed started reducing until the aircraft lost speed and started going down. He added, "It didn't climb much, just a few feet once we started positive climb, and then I felt the aircraft just sinking." His referral to the fact that sometimes TOGA selection limits the power available is acknowledgement of a design feature whereby the first press of the TOGA switch will provide a reduced go-around power setting, ensuring approximately 2,000 feet per minute rate of climb, utilizing somewhat less than the full power available. Where this performance is deemed inadequate, a second push of the switch or manual advancement of the thrust levers will subsequently ensure maximum power. In March 2015, during his pre-command training, the commander practiced rejected landings from heights below 50 feet, but without the aircraft having touched down. His most recent bounce landing recovery training and his last wind shear recovery training were also carried out in March of 2015, 17 months before the accident. He stated that he had never practiced normal go-arounds following the aircraft's touchdown, with the autothrottle previously armed and active. Records showed that he had practiced go-around execution from the runway surface after touchdown, during refresher training way back in August of 2014, prior to him being promoted. However, these scenarios were different from the circumstances of the accident flight, because the training was accomplished with the autothrottle, flight directors and autopilot deliberately switched off. With regard to the co-pilot, records indicated that his only rejected landing exercises from heights below 50 feet but before touchdown were carried out during his initial 777 conversion course. Since then, recurring training sessions had not facilitated any opportunity to practice either automatic or manual go-arounds flown from below 50 feet above the runway, with the aircraft having already touched down, or for a bounced landing recovery. At 12:37 and 38 seconds, just 18 seconds after initiation of the go-around, the 777's aft fuselage impacted the runway at a speed of 124 knots indicated, which fortuitously was still above the aircraft's stall speed, allowing the aircraft to remain controllable for the final descent. Only 7 seconds had passed since the aircraft had started to sink from its maximum attained height of 85 feet radio altitude. The flight data recorder indicated that power output for both engines had started to respond to the manual thrust lever movement, but the height remaining did not provide enough time for the engine thrust to increase sufficiently to prevent the aircraft from striking onto the runway. The aircraft manufacturer's post-accident performance evaluation calculated that, as the aircraft gained height at approximately 58 feet radio altitude when the landing gear was selected into the up position, a successful go-around could have been flown had the thrust levers been advanced to the required go-around thrust setting and the correct go-around pitch attitude being maintained. Performance analysis indicated that as the engines accelerated, the aircraft would certainly have lost some height, but would have cleared the runway at a minimum height of 17 feet radio altitude before safely climbing away. This hypothetical recovery scenario was possible had the crew of Emirates 521 been aware of the aircraft's state, but this unfortunately was not the case. The initial impact point of the aircraft on runway 12 left was abeam the intersection with taxiway November 7, with the landing gear in transition to the up position. The right, number 2 engine, contacted the runway with the engine pylon assembly separating from the wing as the aircraft slid along the runway for approximately 800 metres, while at the same time slowly rotating right through almost 130 degrees, coming to an eventual stop adjacent taxiway Mike 13, approximately 70 metres to the right of the runway centreline. At 12:39 and 04 seconds, 1 minute and 26 seconds after the aircraft had impacted the runway surface, the commander transmitted a Mayday call and informed ATC that the aircraft was being evacuated. The flight crew completed the evacuation checklist within about 60 seconds from the time that the distress call was transmitted and instructed the cabin crew to commence an evacuation. The fire commander and the first 2 airport rescue and firefighting service vehicles arrived at the accident site within 90 seconds of the aircraft coming to rest and immediately started to apply fire extinguishing agent, with additional firefighting vehicles arriving shortly thereafter. After the aircraft came to rest, the fire continued on the separated number 2 engine. Video footage recorded by a passenger showed the aft lower section of the number 1 engine, which was still attached to the left wing, also on fire. From the collective statements of cabin crew and passengers, white smoke appeared in the cabin immediately after the aircraft came to rest. This was confirmed by a passenger video which showed white smoke in the right centre cabin before the evacuation was announced. The source of the smoke was not determined. However, the forward and aft cabins did not appear to be simultaneously affected at this time. After the evacuation command, all passenger doors were opened, except doors 3 left and 3 right. Inside the cabin, the earlier white smoke now became more dense and darker in colour. As a result, visibility throughout the entire cabin was dramatically reduced as the smoke spread. Cabin crew members at the aft galley, between doors 5 left and 5 right, searched the cabin for passengers, but as the environment inside the cabin continued to rapidly deteriorate, they were prevented from searching beyond the doors 4 left and 4 right. The design of the 777 is such that during a standard evacuation with the aircraft supported by its landing gear, the distance from the bottom of the exit door to ground level increases slightly from forward to aft. At doors 1 left and 1 right, this distance is roughly 4.7 metres, and moving aft increases to 5.4 metres at the rearmost doors 5 left and 5 right, with this height obviously varying depending on the aircraft's actual weight. This corresponds to escape slide slope angles ranging from between 27 and 35 degrees from forward to aft doors. However, because in this instance the aircraft was now resting on its lower fuselage, the door height above ground level had been reduced significantly to between 2.5 and 2.6 metres from forward to aft. Consequently, the escape slide slope angle for all doors was also reduced to approximately 14 degrees. During the evacuation, the wind direction at ground level varied between 285 and 305 degrees, with the wind speed varying between 12 and 15 knots, at times gusting up to 18. What transpired was that smoke emanating from the centre cabin area had formed a barrier between the forward and aft sections of the cabin. This left passengers in the aft cabin with only 2 available exits, doors 5 left and 5 right, for most of the evacuation period. As cabin crew subsequently recalled events in the cabin in the immediate aftermath of the jet's impact with the runway, they stated that, even as it slid along the runway, some passengers had unfastened their seatbelts and left their seats. An announcement was made for passengers to remain seated. However, as the aircraft finally came to rest, many passengers reacted instead by grabbing their belongings and demanding that the cabin doors be opened. Although all passengers were, per procedure, instructed to leave their carry-on baggage behind, several ignored the directions of the crew and either did evacuate or attempted to do so while carrying their belongings with them, in so doing greatly increasing the danger to both themselves and those around them. The cabin crew member at door 1 left was unable to fully open the door after it had moved only a few inches. She requested assistance from the senior cabin crew member and the crew member at door 1 right. Together, they were successful in opening the door fully, and the escape slide deployed automatically per design. However, once inflated, it was subsequently affected by the prevailing wind and became detached from the aircraft's structure, remaining inflated on the pavement immediately below the door throughout the evacuation and firefighting operation. The cabin crew member in attendance consequently blocked door 1 left in order to prevent any passenger egress through it. A cabin crew member at door 1 right successfully opened the door and the escape slide deployed automatically. During deployment, this slide also was affected by the wind, being lifted up and blown forward. It was thus also blocked by the attending crew member, with passengers being redirected to door 2 right. About 40 seconds later, the slide at 1 right was belatedly stabilized on the ground and became available for approximately 60 seconds, during which time a number of passengers did manage to successfully evacuate through it. Due to its proximity to an adjacent taxiway sign, this slide was subsequently punctured and then deflated, with the attending crew member being forced once again to block the exit to prevent its usage. Door 2 left required 2 crew members to open it. The escape slide deployed automatically, but was affected once again by the wind and was lifted up against the fuselage, preventing its use for evacuation, with the crew member in attendance once again being forced to deny its usage. When door 2 right was opened, the escape slide again deployed automatically. However, dense smoke from the fire outside made this exit also unusable, with the crew member in attendance being forced to redirect passengers to another door. When the smoke outside eventually cleared somewhat, some passengers and crew did successfully manage to escape through it, some 60 seconds or so after it had been opened. Due to the fire and smoke from the area of the left-hand engine, the crew member at door 3 left made a conscious decision not to attempt opening it. She instead blocked the door and redirected passengers to door 2 right. The crew member at door 3 right did open that door, but in this instance the slide failed to deploy. Noticing the fire outside, she subsequently closed the door again with the assistance of 2 nearby passengers. She, like her colleagues, blocked the exit and redirected passengers to the aft cabin. A post-accident inspection of this slide and video of the evacuation indicated that the slide had remained stowed in its location below the foot of the door. There was no obvious signs of fire damage to the door during the evacuation, which may have impacted upon the slide's operation. However, it was subsequently consumed by the post-accident fire, preventing any further detailed examination. The crew member in attendance at door 4 left successfully opened the door, and the escape slide deployed automatically. During its deployment, this slide was also immediately impacted by the wind, being lifted up against the fuselage, resulting in it also having to be blocked. The crew member at door 4 right stated that she actually didn't hear the evacuation command because of the noise being created by the panicking passengers. She eventually did open the door after she had observed the cabin crew member at door 4 left opening hers. Several passengers evacuated from door 4 right, but the evacuation process was hampered when the slide bowed, making it temporarily unusable for a period of about 40 seconds. When this occurred, the crew member assigned to the door redirected the remaining passengers to door 5 right, as the slide eventually did become usable once again. In an act of selfless heroism, the crew member in attendance jumped into the slide to assist with passenger egress, before climbing back up the slide and into the burning aircraft in order to continue the passenger evacuation from inside the cabin. The crew member assigned to door 5 left opened the door, with the escape slide once again automatically deploying. A number of passengers evacuated through this exit, but when the passengers left the slide, it became wind affected and was lifted against the fuselage, preventing its further use. The crew member at door 5 right opened the door, and its escape slide automatically deployed. However, it was likewise immediately lifted and twisted by the wind, with passengers subsequently being redirected to door 5 left, whilst this exit was still available. A firefighter later stabilised the 5 right slide, securing it for use once again, 3 minutes and 20 seconds after the evacuation had commenced. All of the cabin crew members in the aft cabin evacuated via door 5 right, approximately 25 seconds after the last passenger had been evacuated. The captain and the senior cabin crew member remained in the aircraft, donned protective breathing equipment, and commenced a search for any remaining passengers. They were concerned about a little girl who had become separated from her family during the evacuation process. However, as the smoke in the centre cabin became more dense, both were forced to abandon their search and return to the area of the forward cabin. Approximately 9 minutes and 40 seconds after the aircraft came to rest, the centre wing tank exploded. This caused a wall of smoke to enter the cabin, forcing both the captain and senior cabin crew member to move further forward into the cockpit. They attempted to evacuate through the cockpit windows, but were unable to locate the evacuation ropes above the windows due to the smoke. As such, they decided to return to the cabin and jump from the nearest exit, which happened to be door 1 left, fortuitously landing on the detached slide lying on the ground beneath. Except for the captain and the senior cabin crew member who evacuated after the centre wing tank explosion, all other occupants had evacuated the aircraft via the operational escape slides in approximately 6 minutes and 40 seconds. The aircraft itself sustained substantial structural damage as a result of its impact with and subsequent movement along the runway, ultimately being consumed by the post-accident fire which ensued. 21 passengers, 1 flight crew member and 6 cabin crew members sustained minor injuries, with 4 cabin crew members sustaining serious injuries. But as the hours rolled on, the subsequent head count revealed that everyone on board had gotten out safely. Regrettably, the force of the fuel tank explosion was such that it caused a large section of the right wing upper skin to be liberated. As the panel fell to the ground, it struck and fatally injured a firefighter. Yazim Isa Mohammed Hassan was to be the only casualty of Emirates Flight 521. The aircraft was airworthy when dispatched for the flight, and there was no evidence of any defect or malfunction that could have contributed to the accident. In addition, the fuselage was structurally intact prior to the accident and mostly remained so after impact, but was eventually destroyed due to the subsequent post-accident fire. The 777 was equipped with a long landing alerting system, which did actually enunciate an alert as 521 floated, at a distance of 1,280 metres beyond the landing threshold of 12 left. However, this was more than 92 metres further along the runway than the programmed alert distance, meaning that the protection it was designed to provide was late in coming. In relation to the toga switches, although destroyed in the post-accident fire, it was deemed that these switches were most likely serviceable when the commander pushed the left switch to initiate the go-round. This assertion was based on the absence of any historical maintenance records to indicate otherwise, and also the absence of any abnormal behaviour during the previous takeoff. Per design, the toga switches, as we now know, are inhibited prior to touchdown when the aircraft radio altitude is less than 2 feet, and a continuous 3 seconds have elapsed on the clock. Likewise, they're also designed to become inhibited after touchdown when the aircraft's radio altitude is less than 2 feet, and either main landing gear senses that the aircraft is in ground mode. If the aircraft were to subsequently get airborne again, with an increase in height of 2 feet, the switches are once again re-enabled. With the thrust levers at the idle thrust position and the aircraft above 2 feet radio altitude with the flaps extended, when either toga switch is pushed for a go-around, the auto throttle will automatically advance both thrust levers to the toga position, with this toga thrust being attained within approximately 8 seconds. With the auto throttle disengaged, the pilot's manual advancement of the thrust levers from the idle thrust position to the toga thrust position takes approximately 2 seconds, with the actual application of toga power taking an additional 6 seconds after that. It's important to note that with the auto throttle armed and active, after touchdown or when the toga switches are inhibited, the only means of increasing engine thrust for a go-around are to physically advance the thrust levers manually. This has the effect of causing the auto throttle to disconnect, with the generation of an alert to this effect. However, of specific importance in the context of Emirates 521, generally with regard cockpit alerts, the 777 is not designed to provide the crew with a configuration warning in circumstances where a go-around has been attempted without engine thrust having been advanced towards the toga thrust position. The 777 does, however, provide an airspeed low alert to the flight crew when the aircraft's indicated airspeed has depleted to a very low level. In this context, for low airspeed, think high angle of attack. Although Emirates 521 did not enter an aerodynamic stall, this alert was triggered as the aircraft decelerated through 128 knots, some 34 knots below the planned approach speed. On the 777, the predictive wind shear system is inhibited from giving wind shear warnings or alerts below 50 feet radio altitude, while the enhanced ground proximity warning system is inhibited from providing an actual wind shear warning or alert below 10 feet radio altitude. What subsequently came to light was the fact that for the entirety of the wind shear encounter, 521 was actually floating at a height somewhat less than this value, although in truth these figures are academic, on the basis that the wind shear alerting system is capable of providing a valid alert only where aircraft performance is seen to decrease due to a decreasing headwind or increasing tailwind and severe downdrafts. 521 on the other hand had experienced the complete opposite, an increasing performance shear due to the prevailing tailwind on the approach giving way to an ever-increasing headwind component. Identification and alerting of such environmental conditions is an optional system extra, and in the case of the Emirates 777 fleet, was not fitted to the company's aircraft. With regard to the aircraft's emergency equipment, the 777's escape slides were certified by the US Federal Aviation Administration for a maximum wind speed of 25 knots, blowing from the most unfavourable direction. It was stated that during the evacuation, the prevailing wind speed and direction at the time were within these certification criteria. The slide at door 3 right did not deploy automatically because the pressure cylinder had been damaged due to the aircraft's impact with the runway surface. The protective breathing equipment units on board the aircraft were also certified by the FAA. However, reports stated that due to the ingress of firefighting agent into the cabin, some of these units could not be used because the stowage containers or plastic pouches they were located in were found to be difficult to open. Records showed that Emirates 521 was the first time that the captain and co-pilot had flown together. Crew training records for both crew members indicated that they had met the competency standards established by the operator. Both had performed go-around and missed approach exercises during their training, and operationally, each had performed a go-around as pilot flying on the 777 during normal line operations, with both of these go-arounds coincidentally having occurred 4 months prior to the accident flight. Previously, the captain had undertaken training in relation to go-arounds being initiated from a point after the aircraft's touchdown, with all engines operating. The co-pilot, however, had not. That said, of note was the fact that the training scenarios depicted during the captain's training differed significantly from the experience he had had on the accident flight. Historical data extracted from the company's flight data monitoring program showed that neither pilot had ever previously landed the aircraft excessively long, and as such, there was no evidence of any habitual substandard handling on either's part. Investigation into the cabin crew's management of the evacuation proved very complimentary, praising their professionalism, recall and execution of trained procedures. Of note, however, was the fact that none had received training in evacuation situations where the escape slides had been adversely affected by the prevailing winds. In the context of how the flight was managed leading up to the accident, the investigation team noted that approximately 60 minutes prior to landing, the crew briefed for potential approaches to both runways 30 left and 12 left, which included a review of the wind shear escape maneuver. An approach speed of 152 knots, that being VREF plus 5, was selected for a normal landing configuration with a flap 30 setting. As the aircraft descended through 930 feet radio altitude, the autopilot was disengaged, with the remainder of the approach being flown manually. Usage of the autothrottle, however, was retained, with the remaining engaged until touchdown. The aircraft passed over the threshold at approximately 54 feet radio altitude and an airspeed of 159 knots, 7 knots in excess of the planned approach speed. In light of the prevailing tailwind conditions and the increased rate of descent that this would have given rise to, the captain had started to flare the aircraft slightly early at approximately 40 feet radio altitude. By comparison, the 777 flight crew training manual recommends normal initiation of the flare when the main gear is approximately 20 to 30 feet above the runway surface, in zero wind conditions. This commencement of the flare manoeuvre occurred approximately 100 metres beyond the threshold of runway 12 left. At 25 feet radio altitude, the autothrottle per design engaged in idle mode and both engines started to spool down. As a result, the aircraft's indicated airspeed began to decrease, reaching a value of 153 knots as the jet descended through 10 feet radio altitude. Probably most surprising was the fact that the shear condition was so insidious that prior to activation of the inhibit logics, neither of the aircraft's predictive nor reactive wind shear warning systems provided any warning and/or alert, simply because the conditions which prevailed at the time didn't meet the system's alerting criteria. As the aircraft descended through 7 feet radio altitude, the tailwind conditions started to give way to a modest performance-increasing headwind, slowing the jet's rate of descent. As a result, the aircraft floated over the runway surface for a period of time, with a resultant increase in airspeed which reached 165 knots, 13 knots above the designated approach speed, as the aircraft descended through 2 feet radio altitude. All in all, therefore, this subtle change in wind direction had thus increased the 777's airspeed by a total of 12 knots over a brief period of only 4 seconds. Being visually focused outside of the cockpit while trying to execute the flare manoeuvre, neither of the pilots had noticed. That said, however, the captain had become aware that the aircraft, for reasons unknown to him, had failed to settle onto the runway surface and had reacted by making a small number of pitch inputs on the control column in an effort to force the aircraft onto the ground. 10 seconds after initiation of the flare, now approximately 1100 metres beyond the threshold, and at an indicated airspeed of 161 knots, the toga switches were inhibited per design, as the right-hand main landing gear contacted the runway, causing the gear to untilt or enter the ground mode. With the aircraft failing to settle onto the runway and the captain's perception that it wouldn't do so within the designated touchdown zone, he subsequently decided to terminate the landing attempt and execute a missed approach. Importantly, in his post-accident interview, the captain stated that he was of the opinion that the aircraft's inability to settle onto the runway was due to the effect of localized thermals and not any awareness on his part of a wind shear encounter. Thus, he had elected to fly a normal go-around and not the wind shear escape maneuver. The significant difference between the two being that in the former the aircraft is reconfigured, flaps and gear being retracted as part of the procedure, whilst in the latter, these actions are delayed until the aircraft's transit of the shear has been confirmed. At the moment the captain had initiated the go-round, his perception was that the aircraft was still airborne and that it had not yet touched down, a perception which was subsequently proven to be false. Evidence would show that in attempting to trigger the go-around, he had pushed the left toga switch approximately 2.5 seconds after the aircraft's right-hand main landing gear had made contact with the runway. Again, with their attention focused outside of the aircraft, as the 777 effectively oscillated from one main landing gear to the other, the flight crew had failed to notice that the speed brake lever had partially deployed twice during the 6 seconds that the aircraft's main landing gear had cycled between tilt and untilt. The captain said that he had subsequently become focused on the go-round manoeuvre and described his cognitive state as tunnel-visioned. He further stated that his right hand had remained on the thrust levers during the entire event. Yet despite this, inexplicably after pushing the left toga switch, he had not recognised that there was no tactile feedback of thrust lever movement. Most probably, he said, because he was focused on the aircraft's pitch attitude in attempting to avoid a tail strike, while rotating the aircraft into the go-around attitude. Internally, neither pilot had picked up on the fact that the aircraft had not actually transitioned into the go-around mode. It was not noticed that the flight mode enunciator modes had not changed, that the flight director was not giving the correct go-around pitch guidance, nor that the autothrottle had remained in the previous idle mode, rather than commence delivery of the commanded go-around power. Contrary to standard go-around execution procedures, after calling for flap 20, the crew omitted the steps of engine thrust verification, but rather continued to action the procedure with verification of the aircraft's positive climb. This was confirmed through examination of the flight's cockpit voice recorder, which highlighted that the timing between the co-pilot's confirmation of flap 20 and the captain's call for gear up was a mere 2.5 seconds, insufficient to accurately assess and adjust if necessary the demanded engine power setting. Having assumed that the autothrottle was increasing engine power to the desired setting, but not having verified that this action had indeed taken place, neither pilot had thus subsequently identified any need to intervene and adjust the thrust levers manually. As such, as the captain pitched the nose of the aircraft up towards the normal go-around attitude, the aircraft's energy and speed began to bleed away as it entered a gentle climb. 4 seconds after the aircraft had once again become airborne, on passing 58 feet radio altitude and immediately after the captain had called for gear retraction, Air Traffic Control initiated communications with 521. This communication contained a modified missed approach clearance, which undoubtedly added to the flight crew's workload as they attentively listened and responded to the instructions being given, instructions which physically required a new missed approach altitude to be set for acquisition. The co-pilot had responded to their call, having firstly selected the landing gear lever into the up position. In an ever-decreasing energy state, 521's rate of climb continued to shallow to the point where at 85 feet radio altitude it was no longer climbing at all, but now instead had started to sink back onto the runway. As the aircraft descended, at approximately 67 feet radio altitude, 3 seconds before impact, the aircraft's loss of airspeed was noticed and perceived by the captain as a wind shear effect, which prompted him to call out "wind shear toga," a belated command that the wind shear escape manoeuvre be executed. He again pushed the toga switch, but this time also manually advanced both thrust levers fully forward, as per the operator's wind shear escape manoeuvre procedure. Only at this time did the realization come that the engines were not producing sufficient thrust. Despite his efforts, the aircraft impacted the runway some 18 seconds after the initial go-around command, with the landing gear still in transition to the retracted position. The operator's policy required that the autothrottle be engaged for engine thrust management during all phases of flight, including approach and landing. However, this policy hadn't considered necessary pilot actions where a normal go-round to be initiated while the toga switches were inhibited. Furthermore, the operator's training material for the 777 was based on the aircraft manufacturer's and FAA-approved training program, the content of which had surprisingly not made any reference to this inhibition logic. From a procedural perspective, the operator required the flight mode enunciator changes be announced by the pilot flying and checked by the pilot monitoring in all circumstances, except during landing where the aircraft was below 200 feet. However, despite having aligned their training program with that of the manufacturer, it was also noted that the latter's flight crew operations manual and the flight crew training manual didn't actually require any monitoring or call out of FMA changes on indication of a go-around at all. In hindsight, the absence of any such monitoring would have greatly compromised a crew's ability to readily identify the circumstances surrounding this particular type of accident. Thus, overall, the investigation team believed that the current 777 training programs were ineffective in preparing crews to deal with potential go-around scenarios which may present after touchdown, despite the fact that such programs had already been accepted and ratified by the local competent authority. They further identified that not all information relating to the toga switch inhibit logic was available either in the flight crew operations manual or in the flight crew training manual, with no specific reference being found to explain exactly why the autothrottle mode will not change once the toga switch has become inhibited. In short, 777 pilots had not previously been made aware of the fact that the toga switches would become inhibited once the aircraft's time below 2 feet radio altitude had exceeded 3 seconds, and in a similar vein, no reference could be found to highlight the fact that this condition was reversible once the aircraft had again climbed above 2 feet radio altitude. The operator's normal go-round training hadn't contained information with regard to the time it would take for the engines to achieve toga thrust, either by manual advancement of the thrust levers or by use of the auto throttle after the toga switches had been pushed. And more importantly, it was also found that this training was deficient in providing any guidance to exactly how to perform a normal go-around with the toga switches inhibited, either prior to or just after touchdown. Finally, after touchdown with manual advancement of the thrust levers to the toga position, and without pushing the toga switch, an auto throttle disconnect message is presented to the crew. However, the presentation of such an alert is not mentioned in the operator's 777 training manuals, including the Flight Crew Training Manual and the Flight Crew Operations Manual. In summary, therefore, what the subsequent accident investigation had revealed was a level of training deficiency both from an academic and practical perspective, which would most likely have negatively impacted on the crew's performance under the circumstances. In summarising its conclusions, the General Civil Aviation Authority of the United Arab Emirates found that on the afternoon of the accident, August 3rd, 2016, a warning of moderate wind shear for all runways had been broadcast as part of Dubai International's ATIS Information Zulu, exactly 37 minutes before Emirates 521 had attempted to land. Despite this, the fact that pilot reports clearly identified the presence of wind shear, and significantly, that two aircraft had gone around shortly thereafter, the authority were critical that this crucial information had not been passed to the crew of Emirates 521 in advance of their attempted landing. In fact, a significant amount of essential information hadn't been communicated to the crew of 521. This information not only included the missed approaches and reports of wind shear and short final, but also any reference to the shifting surface winds at the threshold of runway 12 left, from headwind to tailwind, starting from 12:29 local time. Finally, although the authorities believe that ATC's intervention in the immediate seconds following initiation of the go-around had in no discernible way directly impacted on events, one would have to say that at the very least it was an untimely and unwelcome distraction. As such, they did caution ATC to be mindful of such potentially high workload scenarios and to modify their practices accordingly. In total, the General Civil Aviation Authority of the United Arab Emirates, following the conclusion of its investigation into the crash of Emirates 521, made a total of 40 safety recommendations. Of significance was their aspiration that the operator disseminate to its pilots knowledge and information about factors affecting landing distance and flare duration, such as aircraft height and airspeed over the threshold, early flare initiation, and weather conditions that may affect aircraft performance during the landing. Also, they recommended that training programs be enhanced to include scenarios where go-arounds are initiated from close to the runway surface, or indeed after main landing gear touchdown, scenarios where the aircraft's toga switches would be inhibited. This training should also include guidance information on engine response times to achieve go-around thrust. The operator was also encouraged to enhance training standards regarding toga switch inhibition, so the pilots be aware of the effect on FMA enunciations and flight director behaviour, and in addition, cultivate an awareness as to when this switch inhibition will cease. They were of the opinion that crews should be reminded of the effects wind changes can have on aircraft performance, and the importance of effective monitoring of flight instrumentation during such wind shear events. Furthermore, from a practical perspective, simulator training scenarios for go-rounds executed either before or after touchdown should emphasise the importance of performing and verifying each procedural step. With regard to training requirements for cabin crew, focus should be placed on evacuation scenarios where the escape slides have been adversely affected by the prevailing wind conditions. With regard to ATC procedures, these should be reviewed so that whenever wind shear warnings are in effect at an airdrome, essential safety information such as go-rounds, long or deep landings when reported, and wind gusts and shifts will always be transmitted to the flight crew at an appropriate time during the approach. In a similar vein, procedures should be reviewed so as to require controllers, whenever wind shear warnings are in effect at an airdrome, and it is deemed safe to do so, to query the reason for an aircraft go-around if such information is not previously passed by the crew themselves. Further, the GCAA investigation team made the following recommendations to both the manufacturer and certifying authority, namely the US Federal Aviation Administration. Firstly, that the 777 crew alerting system be amended to include aircraft configuration inconsistency, where a go-around manoeuvre is commanded and the engine thrust is insufficient for the manoeuvre to be completed successfully. Also, that the published pilot support manual in the form of the Flight Crew Operations Manual and Flight Crew Training Manual should highlight all relevant information in relation to the toga switch inhibition logic and the associated effect such inhibition will have on autothrottle operation. And finally, they recommended that a study be undertaken with the intention of enhancing both the 777 wind shear alerting system and toga switch inhibit logic that will avoid pilot errors due to an over-reliance on automation. The study should also include improvements to crew procedures and training of the autothrottle system and toga switch inhibition logic, with consideration being given to manual advancement of the thrust levers for go-arounds initiated from low altitude or indeed after touchdown. Undoubtedly, as with all aircraft accidents, each event is ultimately the sum of its parts, and in this regard Emirates 521 was no different. Exposed to environmental influences, the crew of 521 found themselves drawn into a scenario which they had never experienced or trained for previously. Handicapped by a false perception of aircraft state and a genuine ignorance of system design and operation, assumptions and over-reliance had resulted in mismanagement of the aircraft's automated modes. Failure in crew monitoring procedures had subsequently allowed this mismanagement to go unnoticed, resulting in the devastating consequences witnessed that afternoon. This was the complete story of Emirates Flight 521, the Arabian Miracle, Dubai, August 3rd, 2016.